What is the difference between organic and inorganic? Imagine walking through a garden and noticing the plants, the soil, and even the rocks. Have you ever wondered what makes some chemicals part of living things and others not? Today, we're going to uncover what sets organic and inorganic compounds apart in the world of physical sciences and chemistry. The main difference lies in their chemical makeup and where they come from. Organic compounds mainly contain carbon atoms bonded to hydrogen atoms. They often include other elements like oxygen and nitrogen too. These compounds are the building blocks of life. Think of sugars, fats, proteins, and DNA. They are usually large, complex molecules that form in living organisms or are made to mimic life's chemistry. Inorganic compounds are quite different. They generally do not have carbon-hydrogen bonds. Instead, they are made up of elements like metals, salts, minerals, and gases. For example, table salt, which is sodium chloride, is inorganic. Metals like iron or copper are inorganic too. These compounds often form through ionic bonds, where one atom gives electrons to another, creating charged particles called ions. When you look at their structures, organic compounds tend to have covalent bonds, sharing electrons between atoms. These bonds make the molecules more flexible and capable of forming large chains or rings. Inorganic compounds, on the other hand, often form crystalline structures with ionic bonds, making them more rigid and stable. In nature, organic compounds are mostly found in living things. Plants, animals, and humans all relying on organic molecules for energy and growth. Inorganic compounds are common in the Earth's crust, like minerals and metals, and in the atmosphere, like gases. Physically, organic compounds usually have lower melting and boiling points. They are often less soluble in water but dissolve well in organic solvents like alcohol or acetone. Inorganic compounds tend to have higher melting points and are more soluble in water, which makes them useful in many industrial processes. Reactivity also differs. Organic compounds tend to react more slowly and in more complex ways. Inorganic compounds often react quickly, especially with acids and bases. For example, acids like hydrochloric acid are inorganic, while sugars like glucose are organic. To sum it up, organic compounds are mainly made of carbon and hydrogen, linked in ways that support life. Inorganic compounds cover a wider range of elements and structures, usually without carbon-hydrogen bonds. This distinction helps us understand everything from how our bodies work to how the Earth is formed. Whether it's the fats in your food or the minerals in the ground, knowing the difference makes chemistry a lot more fascinating.